How's it going? My name is Joe Shuddy, and today I'm going to be showing you a few cool things that I've made in Minecraft over the years. In particular, I'm going to show you this calculator over here, this calculator right here, and then this little game that I set up here. So before I get into that, I just want to show you real quick how all this stuff works. So this is based off of what's called Redstone, which is Minecraft's wiring system. It kind of works in binary. You have an off state, which is this, and you have an on state, which is this. There's a little bit of a caveat to that where there is something called signal strength. So basically, the further out I get from what's powering this wire, it's almost like it's like a resistive load, like the wire's a resistive load, so it's going to die out. But if I were to set up like a light or something like that at the edge of this line and at the start of this line, that's where it acts kind of like binary, where it's either going to be on or it's going to be off if it's not powered. And so basically everything that I'm going to show you works off of stuff like that. There's a little bit of extra stuff, so like for example, this is a lever here. So if I have something like this, this is a NOT gate, where basically this torch inverts whatever I put in as a signal. So with this being on, it turns the output off. With this being off, it turns the output on. So a lot of this stuff works off of logic gates like that. So before I get into the complicated ones, I'm going to show you the simple one, quote unquote simple. Basically the way that this works is actually just like how a regular calculator works. So this calculator can do addition with two numbers that can go up to 8. So its maximum value that it can hold is 16 right there at the end. So if I were to, for example, we'll do 5 plus 2. It's got a little bit of noise in the signal, but eventually it's going to go to 7. It's going to turn on the 7 light. And the way that this works is basically this is a regular number, and then this module here converts that number into binary, which is shown by the two cauldrons is what they are, that are sticking up. So if I were to change this to like a 2, for example, if you can picture this being your 1-bit, your 2-bit, your 4-bit, and your 8-bit, the 2 1 pops up. If I were to do like 7, for example, then your 1, 2, and 4-bit are going to pop up. It takes those signals and puts them into a bunch of logic gates, like XOR gates and stuff like that, to actually do that addition in binary. And then this module right here converts that back into, I'm spacing on the name, but a 10-digit system. And that line will be transferred back through here, which is a pretty big line, and give you that output. So with the more complicated, bigger one over there, I wanted to mainly try and figure out a way to reduce the size of the wiring. So like for example, you can see right here I have 16 outputs, and that requires 16 lines, which is a lot of space that I didn't want to end up taking up. So that was one of the big things I wanted to solve. And so I did a little bit of research and found something. It's essentially pulse width modulation in Minecraft, if you know what pulse width modulation is. But basically what this allows me to do is I can put in some input and it'll send the signal and decode it. So like if I were to push the second button like I just did, it's going to turn on the second light. If I push this button all the way over here, it's going to be able to turn on that light. And the way that it does this is by measuring the signal strength, so that stuff that I showed you here. So it's able to say, hey, this has a signal strength of 15, whereas this right here has a signal strength of 8. And it's basically able to encode that and then decode it on the other side. So if I hit a signal right here, that'll give me a signal strength of 3, which will decode into a 3/10 of a second, I think, pulse, I guess. So if I do this, it's going to be a really short pulse, whereas if I do something all the way over here, you can see that pulse is a lot longer. And that's how it's able to send 15 different signals on one line instead of every single signal being a line. This is a 7-segment display in Minecraft. I'm not going to take credit for this. This was something that I just looked up how to do because I had no idea how to do it. And this is a really compact design that I found on YouTube. This is my design for a 15-button selector panel. So if I push the 9 button right here, it's going to basically take that pulse width modulation thing over there, and it puts it into a little box that looks a little bit nicer. And then finally, we make it all the way over to here. So this is a calculator that can do 15 plus or minus 15. And it can handle negative numbers. If I were to do like 8 minus 15, for example, it's able to handle that negative number. So I'll show it off here first. So I'll do maybe a 6. So the way that this works is I select a number, and then I come over here and I select which memory slot I want it to go into. So if I want a 6 to be the first number, then I'll push this number 1 right here, and an off lamp indicates that that's the one that's selected. I give it a second because it takes a while for all the wiring to work, and then I hit select, and then it's going to take a few seconds here, but it's going to write that 6 to the first section of memory, and so it'll be able to say that, hey, this first number is a 6. So then I'll say 13 will be the second number. So then I come over here and I write that number 2, give it a few seconds. I don't remember how long it actually takes, so I'm just going to be generous with that, and then hit select. And it's already trying to do 6 minus 0 right there, so it's going to say it's negative 6. A little bit of noise in the output there. I had a lot of difficulty trying to fix that, but ended up not being able to figure out what was going on there. So it wrote to the second section of memory, so now it's saying 6 minus 13 equals negative 7, which is correct. The other thing that I can do right here is I have minus selected, so if I switch that over to plus, it'll make that a plus sign, and then it'll take a few more seconds to refigure out what's going on, and then say 6 plus 13 equals 19, just like that. So there's a lot going on here. These are each the 7-segment displays, and then basically it takes the number that you give it and then runs it over into here. This is the decoder thing that I was talking about a little bit earlier, and then there's just a lot of wiring that takes a while to explain, and is very, very confusing unless you are pretty knowledgeable in Redstone, I guess. So basically that takes that number, decodes it into binary, and then this is actually your memory right here. So I believe it's your 1, 2, 4, and 8-bit for the first number, and then your 8, 4, 2, and 1-bit for the second number. So this would be 13, and this would be 6. It takes those numbers, brings them up here into the adder. So this is a more compact adder that I found on YouTube compared to the one that I was doing over there. And then this yellow module right here is a subtractor if you end up doing subtraction. So it takes that addition right there, and then essentially just brings it over to the 7-segment displays to be able to display it. There's a lot more complicated stuff, like this purple system down here is pretty confusing. This blue system here was something I came up to kind of fix a bug that I was having. Excuse me. But yeah, that's essentially how it works. It took me a long time. It probably took me about 40 hours to basically write out what I wanted it to do, because I was trying to do it with as little research as possible, and see if I could do it all myself, essentially, instead of just looking up a tutorial on how to do it on YouTube. So there's a few things like the 7-segment displays that I didn't come up with initially, but that was stuff that I wasn't really interested in. I just wanted to figure out if I could do like the actual math part of it. And then over here, this was just something that I did just for fun, kind of. This is Lights Out, if you've ever heard of that game. Basically, the way that it works is it's a 5x5 grid, and you want to find a way to turn all the lights off. And the caveat there is when you push a button, it inverts the states of all of the lights around it. So by pushing that button, it turns on all the lights here. If I were to push this button, for example, it's going to turn on these lights, but then flip the state of these, so those will turn off. So you can kind of see how that can get out of control pretty quick. The cool thing that I had here is I made a bunch of presets, and that's actually the beef of this. Is this whole section right here is just a bunch of memory to hold all these presets. So if I were to do like an X, for example, it's going to clear the board and then put an X up, and then I can try and figure out how to turn all the lights off there. If I do like the borders preset, that's going to put up a bunch of borders like that. And then the other one that I did is I just had a randomizer. So basically it'll erase the board and then just put up a random assortment of bits. And that changes every single time that you push it. Just so that you can't memorize the answers to all of those and then not be able to play anymore. So I actually don't remember it in its entirety how this works. This is the main portion of it, but I built this over the span of like 2 days and then didn't ever touch it again. So I actually don't remember how this works, but this is the main computer portion of it. This is the memory portion of it. This is the one really frustrating thing about Minecraft, is that its wiring is humongous. So actually this right here is only, I think, 225 bits of memory. I think it was 9 presets, and then there's a bit of memory for the state of every single one of the lights for those. So 9 times 25 is 225, so that's 225 bits of memory right there. And then this is just the randomizer module in the back. So yeah, that's some cool stuff that I've made in Minecraft. I hope you enjoy.